Good morning, all of you. Today we are here to discuss resolution, composition, resultant in mechanics. It is very much important to learn about resolution, composition, and resultant because we solve all the problems by using these three concepts. We should also know the force and its characteristics, which we have seen in the previous class, followed by the resolution, composition, and resultant of forces. So let us go to the topic. So first of all, let us see what is resolution. So resolution is nothing but splitting of force into two or more components. Simply we can say dividing a force into two or more components, right? So here let me draw it once again. A force F is at an angle of theta, right? Now we need to split this force into two or more components. Why? What is the need of splitting this force into two or more components? Because we can find the magnitude of two forces which are in the same line. If the magnitude is given as 55 and 10 and are in collinear position, then we can simply sum them up and we can say 5 plus 10 is equals to 15 Newton. Okay. Whereas if a force is at an angle, in real time applications the forces will be applied at different angles. They may not be in same line, they may not be in collinear position. So this concept will not be work out in every time. So we need to know how to divide the force and also how to combine the force. So the division is called as resolution, and in the next slide we will see about composition, which is nothing but combining the forces. Okay, now let us see. This force is at an angle of theta. So as per the algebra, we already know the force can be divided into F cos theta and F sin theta. Okay, so this is what called as resolution. So how do we get this F sin theta and F cos theta? Let us draw a line here. So it will look like a triangle and this is force F. So let us name this as ABC, and in this triangle ABC, right angle triangle ABC, we can write a sin theta. First of all, let us write sin theta. So sin theta is equals to opposite. So for this angle, opposite is BC divided by AC. This is the hypotenuse. Similarly, cos theta is equals to adjacent AB divided by AC, hypotenuse. So I want to know the AB, then I can simply write AB is equals to AC cos theta, as well as this as I want to know BC. So BC is equals to AC sin theta. Here what is AC? AC is nothing but force F. So we can divide the force into two components by using the simple trigonometry, which we have already know in the 8th grade. Okay, and there are various diagrams which were shown here, and we already know this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. So based on the quadrants, the direction of forces are being showcased. So in this, the direction of force is in this direction, so it is resolved as, and another important thing is the place of theta is very much important. Here theta is like this, so always adjacent beside theta we need to write F cos theta, and the opposite is F sin theta. As we already know, cos theta is equals to adjacent by hypotenuse and sin theta is equals to opposite by hypotenuse. So always remember, you need to write cos theta beside theta, that is adjacent to theta, and sin theta opposite to theta. So here the angle is with respect to vertical, whereas here the angle is with respect to horizontal. Therefore, we have to mention P cos theta, as the force given here is P, not F. We need to consider P only. P cos theta and opposite is P sin theta. So we need to carefully observe the direction of force. The characteristics of force is very much important. The direction of force, the line of application, the point of application, everything is important. So we will see these examples in the friction PPT, in the friction, in the CO3, because it is little complicated. We will see there. Yes. So as I told you, composition is the opposite of resolution. This is the process of combining several forces and replacing them with a single force, which is called as resultant force. So this F1, let us write it here, F1 cos theta 1. We are resolving the forces which are shown here into components, and this is F1 sin theta 1, and on the other hand this is F2 cos theta 2, as sorry, here the angle must be different, F2 sin theta 2, because here it is given theta 2 with respect to vertical. So here you will get F2 cos theta 2, and then F3 is on y axis, so no need to resolve this into forces, and F4 should be resolved into components. So here F4 cos theta 4, because this is the adjacent one, and here F4 sin theta 4. Okay, now we have to remember one thing. This side is positive, this side is negative. So we all know that this is the x-axis, this is the y-axis. So this is the positive x-axis, this is the negative x-axis, this is the positive y-axis, this is the negative y-axis. Sign convention is very, very important during the process of solving resultant problems. So we need to remind this whenever we are solving the resultant problems. So right side x-axis is positive, left side x-axis is negative, upwards y-axis is positive, downwards y-axis is negative. So this is the sign convention we need to follow apart from the resolution. So while resolving, we have to always remember that cos component will come beside the angle and sin component will come opposite to the angle. So if you know these basics, it is very simple. You can play with mechanics. Now let us see how to find out the resultant. Let us solve the problems in the next slide. So all these forces must be combined to form the resultant. So resultant R is equals to, we cannot write simply F1 plus F2 plus F3 plus F4. Why can't we write? Because all these are vector quantities. We cannot simply write F1 plus, we can write like this, but we have to combine all the components. Okay, right. Yes. So what are the resultant? Let us see the definition. The resultant of several forces is a single force which produces the same effect as that of the effect produced by several forces. It is an equivalent force of all the forces. Suppose here P and Q are the two forces which are acting from a point O and also separated by an angle alpha. Now in order to combine these two forces, we have to use some methods. We cannot simply write the algebraic sum. So there are some methods. Let us see what are those to find out the resultant of two bodies. Two bodies, it is not limited to two bodies. There are several methods which can find the resultant of bodies, more than two also. So these are the analytical and graphical methods for composition of forces. First one is triangle law, second one is parallelogram law, third one is polygon law, and fourth one is method of projection. So in our course we will follow all these 4 methods for finding out the resultant of force. So triangle law and parallelogram law have limitations. They can be applied to only 2 forces. They cannot be applied more than 2 forces. And polygon law can be applied to n number of forces. And method of projection is also for maximum number of forces. Now let us see what is triangle law and what is parallelogram law. So the definition of triangle law is, if 2 forces are acting on a body, and are represented by the sides of a triangle. So this is the actual force diagram. Okay, so these 2 forces must be represented as the sides of a triangle taken in order. That means all the directions of forces must be in one order, and then the resultant force, which is the third side, is called as the joining force, which is joined in opposite direction, is called as resultant. Okay, let us see once again the definition. If 2 forces are acting on a body and are represented by the sides of a triangle taken in order, then their resultant is represented by the third side of the triangle taken in opposite order. So this P is following this direction. So how can we just simply take this Q to other side? So as per the principle of transmissibility, we can transfer the force on the same line of action like this. So this is P now. So that is how this P is drawn, and then Q, and the closing side is called as resultant, which is taken in opposite order. Right. Then what is parallelogram law of forces? This is also similar to triangle law of forces. Here the forces are acting on the body are represented as a adjacent sides of a parallelogram. So P and Q are represented like this. P and Q are represented like this. A parallelogram can be drawn simply by taking the 2 sides equal, and we can close the parallelogram like this. Now 2 forces are represented as the 2 adjacent sides of a parallelogram. Then the resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through the intersection of P and Q. Okay, so let us repeat once again. If the 2 forces are acting on a body at a point and represented in magnitude and direction by 2 adjacent sides of a parallelogram, then their resultant is represented by the diagonal of the parallelogram which passes through the intersection point of P and Q, both in magnitude and direction. So this is what parallelogram law, and we will solve problems on this in the next class. That's all for today.